Have you ever wondered how the stars in the sky are connected to the water in your glass or the air you breathe? How can something as vast as the universe and as tiny as a microorganism be made up of the same building blocks? What if I told you that a journey through these scales, from the cosmos to the tiniest atom, reveals the deepest secrets of our existence? Let's start with a question. Look at your surroundings: the air, the water, the soil. What do you think they're made of? Are they continuous, like a flowing river, or made of tiny separate particles? This is not just a modern question. Over 2,000 years ago, a Greek philosopher named Democritus thought about the same thing. He wondered, could everything around us be divided into smaller and smaller pieces? Or is there a point where we can't divide further? What do you think? Is there an indivisible particle? Think about it for a moment. Let's zoom out and see the big picture. From the vastness of space to the tiniest droplet of water, everything is made up of tiny building blocks called atoms. But what are atoms? Are they really indivisible, as Democritus thought? Let's dive deeper. Look at this water molecule. How do these atoms stick together to form water? Why don't they just fall apart? And why do atoms of one substance behave differently from another? To answer these questions, we first need to understand what atoms are made of. For any buildings, brick act as building block in the same way. Everything you see, from the mountains to the microorganisms in a water droplet, is made of atoms. But atoms aren't just tiny solid particles. They have their own complex structure. Let's zoom in and explore. An atom consists of three main parts to which we call subatomic particles. They are proton, neutron, and electron. Protons are positively charged particles of an atom. It is indicated as P+. Neutrons are neutral, or particles with no charge of an atom. It is indicated as N0. These protons and neutrons together make a nucleus of an atom. Electrons are negatively charged particles that orbit the nucleus in specific regions called shells. The atom is like a tiny solar system. The nucleus is the sun, heavy and central, while electrons are like planets orbiting around it. Here's another puzzle. If atoms are made of positively charged protons and negatively charged electrons, why don't they collapse into themselves due to the attraction between opposite charges?
For years, scientists struggled with this question, but then Niels Bohr proposed a groundbreaking idea. Before we dive into Bohr's revolutionary ideas, let's first revisit Ernest Rutherford's groundbreaking contributions. In 1911, Rutherford conducted the famous gold foil experiment, a turning point in our understanding of atoms. Here's what he did. Rutherford took a thin sheet of gold foil and shot tiny particles, called alpha particles, at it. Most particles passed through the foil, but some bounced back. This surprised him. This led Rutherford to propose his model. 1. Since most alpha particles pass straight through, he concluded that atoms are mostly empty space. 2. Rutherford discovered that the atom's mass and positive charge are concentrated in a tiny region called the nucleus. 3. Electrons move in orbits around the nucleus, balancing the positive charge of protons with their negative charge. Rutherford's model was a major leap forward, but it raised a puzzling question. If electrons are constantly revolving around the nucleus, wouldn't they lose energy and eventually spiral into the nucleus? This made the stability of atoms difficult to explain. This is where Niels Bohr stepped in. To address the stability issue, Bohr expanded upon Rutherford's ideas with a new perspective. He introduced a more refined model of the atom that resolved this fundamental flaw. Bohr's model retained the idea of electrons orbiting the nucleus, but introduced the concept of fixed energy levels to explain atomic stability. Let's break it down. 1. Bohr proposed that electrons revolve around the nucleus in specific paths or orbits, also known as energy levels or shells. These shells are like the rungs of a ladder. Electrons can only exist on these rungs, not in between. Each orbit has a fixed amount of energy, and the farther the orbit is from the nucleus, the higher the energy of the electron in that orbit. 2. Electrons can jump between energy levels. When an electron absorbs energy, it jumps to a higher level. When it falls back to a lower level, it releases energy in the form of light. This is why fireworks and neon lights glow so beautifully. Think of a swing in a park. When you push the swing, it goes higher, gaining energy, and when it comes back down, it loses energy. Electrons behave similarly. 3. By introducing the concept of fixed energy levels, Bohr solved the problem of electrons spiraling into the nucleus. His model explained why atoms are stable. From the smallest atom to the vast universe, understanding atoms helps us unlock the secrets of existence. Keep exploring and stay curious.